In this video, we'll be going over differentiation and we'll be applying it to a 6-mark question. The point P with x coordinate, a half, lies on the curve with the equation y equals 2x squared. The normal to the curve at P intersects the curve at points P and Q. Find the coordinates of Q. To approach this question, we're going to differentiate and find the gradient at point P. So the equation of our curve is y equals 2x squared, and our gradient function dy by dx is equal to 4x. So the gradient at point P, we'll have to substitute a half because that's our x coordinate. So our gradient at when x is equal to a half is equal to 4 times a half, which is equal to 2. And so we have to find the gradient of our normal now, and our normal is perpendicular to the gradient of our tangent. So the gradient of our tangent here we've calculated as 2. And the gradient of our normal can be found by using the equation m2 is equal to minus 1 over m1. So since m1 is just a nice whole number, we can substitute that straight in. So the gradient of our normal is equal to minus 1 over 2. Now we have to find our y coordinate at point P. To do this, we'll substitute our x coordinate into the equation of the curve, and we'll be given our y coordinate. So when x is equal to a half, y is equal to 2 times 1 over 2 squared. So here we substituted x is equal to a half into our equation of the curve, and this gives us y as 1 over 2. Now we're going to find the equation of our normal, and we're going to use the formula y minus y1 So we're going to use y minus y1 equals m times x minus x1. We're now going to substitute our values for x1 and y1. So we have y is equal to minus a half times x plus 3 over 4. So we have our equation of our normal. And what we're going to do now is we're going to equate the equation of our normal to the equation of our curve. And by doing this, we can find the points of intersection of the curve and the normal. So our equation for the curve is y equals 2x squared. And our equation for our normal is y equals minus 1 over 2x plus 3 over 4. Now, since both equations have y, we can equate them together. So we're left with 2x squared is equal to minus 1 over 2x plus 3 over 4. The first thing that we're going to do is we're going to multiply our whole equation here by 4. So we will get 8x squared is equal to minus 2x plus 3. And so now that we've removed all the fractions, we can now rearrange our equation. So we get 8x squared plus 2x minus 3 is equal to 0. And now we've formed a quadratic. So the way we're going to solve the quadratic now is we're going to use splitting the difference. So we have to find two numbers that add to 2 and multiply to minus 24, because this is our coefficient of x multiplied by our constant here. And instead of writing out all the factors, we can just use mental maths here and we can isolate our two numbers. So we can get 6 and minus 4 as our two values. So we can rewrite our quadratic in the form 8x squared minus 4x plus 6x minus 3 equals 0. Now, this form here is easier to deal with than the form we had before, but they are still equivalent. So we can start by factorizing 8x squared minus 4x. So we get 4x out of the brackets, and we have that multiplied by 2x minus 1. And for our 6x minus 3, we can factorize out our 3, and we get 2x minus 1. This gives us two sets of values, so we get 4x plus 3 multiplied by 2x minus 1. And both of them are equal to 0. So now, by isolating our two values here, we have 4x plus 3 equals 0. And we have 2x minus 1 equals 0. So 4x is equal to minus 3, x is equal to minus 3 over 4 for our first number, and 2x is equal to 1, x is equal to a half. So what we can straight away remove is x is equal to a half, because this is the x coordinate of point P. So we only need to worry about x is equal to minus 3 over 4, because this is our x coordinate of point Q. So when x is equal to minus 3 over 4, we're going to use our equation of our normal line here. You can use the equation of your curve, but we're going to use our equation of our normal. So that equation is y equals minus 1 over 2x plus 3 over 4. And we're going to substitute minus 3 over 4 into x. So we have y is equal to minus 1 over 2 multiplied by minus 3 over 4 plus 3 over 4. So when we simplify this down, we get y is equal to positive, so that's 3 over 8, plus 3 over 4, and this is equal to 9 over 8. So our coordinates for Q are minus 3 over 4, comma, 9 over 8.
As always, thank you for watching, and make sure you subscribe so you don't miss out on any new content.